Good afternoon, and welcome to today's webinar, Conveying Headaches for Good, Expert Solutions to Loud Pump Noise, Line Plugging, Resin Damage, and more. Sponsored by Novatec and organized by Plastics News. I'm Joe Pryweller, Senior Director of Conference Content for Plastics News. For decades, processors have lived with the same challenges: loud pumps, material damage, constant maintenance, and plant layouts that feel like workarounds. Many have simply accepted these headaches as part of the job. But today, you're going to hear from people who not only have lived these problems, but are solving them. First, you'll hear from Tim Noddle, Senior Vice President of Business Development at Novatec. Before joining Novatec, Tim spent years as a plastics processor himself, dealing with the same day-to-day issues you're facing now. He knows exactly what those pain points feel like, and today he brings that processor's perspective to the conversation. Tim works closely with Novatec's product experts, Ryan Esmerlian, Conveying Product Manager, and Fred Eichhorn, Engineering Development Manager. Ryan and Fred work directly with processors all over the country every day to solve the same persistent conveying problems we're discovering. Problems they've spent their careers engineering solutions for. During the course of the webinar, you can ask questions by opening the Q&A icon that you'll see at either the bottom or the top of your computer screen, and then typing in your question. Your question will be answered in the order that it is received, after the presentation portion of the webinar is completed. At this point, let me turn the conversation over to Ryan, Fred, and Tim. Tim will moderate today's panel. Tim, the floor is yours.
Thank you, Joe. Appreciate that terrific introduction. And as Joe mentioned, a lot of the challenges that our partners in the processing world have faced, they've had to almost accept as just the way it is for many, many years. But we believe you don't have to live with that anymore. There are technologies and approaches available that really help to overcome a lot of the things that have been a frustration for a long time in the world of resin conveying. So one of the things that we'll focus on over the course of the discussion is a new pump technology that's available called the Infinity Series pump from Novatec that will address a number of these issues. And we'll talk about both the attributes of the pump series, but also how some technologies can be applied to resolve not just pump issues, but conveying issues overall. So without further ado, let's talk about the most obvious one first, guys, which is noise. And Fred, you know, we've talked a number of times about the fact that noise isn't just an annoyance. There are real practical issues with the noise that's generated by the conveying process, right?
Absolutely, absolutely. So that noise can be concerns for a plant and for employees from an OSHA perspective. Mm-hmm. You get fines, things related to that. You also obviously you're going to have workers that can obviously have either some types of hearing issues. They could be missing time. Just productivity in general. It's difficult to think and do your job properly and to hear and communicate to other people in the plant. And then, of course, you have things like retention and hiring people and keeping your staff. You know, it's
huge concern.
Yeah, very miserable. You know, place sometimes.
Yeah, well, huge concern anymore. I mean, right. You know, finding and retaining good quality employees and not having to retrain people constantly because of turnover is a huge focus of many companies, and making the environment more pleasant to work in and more conducive.
Exactly.
Certainly is a big focus, right?
Yeah, I mean, I couldn't imagine working on some of the plants that I visited.
Sure, no,
I mean, full time.
Tough environments, yeah, tough environments. So, Ryan, what are some of the things that contribute to that noise issue, just from the inherent nature of the conveying process?
Well, besides, you know, some of the obvious where you have a material running through metal lines and bouncing around everywhere, that's obviously a noise generator. Mm-hmm. But one of the big ones that we deal with as an equipment supplier is our own vacuum pumps. Mm-hmm. Vacuum pumps can be a big noise generator in your plant, and it could be because of, you know, the motor the motor that's used. It could be the blower because you're generating that vacuum. What type of silencer you have on it, the belts and shiv contact, the belt guard, depending on how it's designed, could act as like a drum.
Sure.
So there's a lot of noise that can be generated just from equipment itself that we could have some control over.
Absolutely, absolutely. So, how have companies taken an approach of putting workarounds in place to deal with some of those inherent issues?
Yeah, so one of the ones that you could do like straight from the factory is put a sound enclosure kit over it. Yeah, you could do that. It'll encapsulate some of the sound. It'll help bring it down to more reasonable levels. But then you are not able to see the pump. You're not, and it will actually become a potential place of heat generation.
Sure.
Where it could, increase.
You keep that heat in, right? Yeah.
Yeah, right. Unless you have some sort of ventilation. Another workaround, which is pretty common, is having your pumps put into a remote room that is farther off away from your destinations.
Sure.
And by doing that, you're extending all your plumbing lines, which can create changes in your velocity gradients and conveying. It could change the sizing of your pumps depending on how far away, if you have to upsize headers, change your plumbing. So there's a whole bunch of different things. But once you put it in that room, it's out of sight.
Well, sure. And so you're now out of sight, out of mind, and you're creating an even more hostile environment because you're putting all the noise in one place. So people don't want to go in there, right?
Yeah.
Right.
No one wants to go in there, but you isolate it to an OSHA approved
Sure.
hearing protection.
Sure.
Yeah.
Sure. And then now you mentioned something about the fact that potentially you move that vacuum generation further away from the process. So now you're creating a whole nother challenge, which is extending the length of your lines, your conveying distances, right?
Yeah, you have to accommodate for the additional resistance that will be generated through the longer line, even though it's just clean air.
Sure, sure. And so now you have velocity issues with the resin, which means you've got a whole nother plethora of challenges, both with the equipment and with the resin, right?
Yeah, especially on material conveying.
Right, you'll be using more energy to move the materials. You're going to do more wear and tear on those pumps in order to move it because those further distances.
Sure, and just the impacting the higher velocity, so you're going to be impacting the lines, and as a consequence, you're creating wear points, right?
Yeah.
Well, and especially, a lot of the new resins that I'm sure a lot of our participants are very familiar with are more and more, we're seeing highly loaded resins, engineered resins, like glass-filled polypropylenes, glass-filled nylons, talc-filled materials. All of these things certainly extremely abrasive, and now you increase velocity, you're just exacerbating that problem. Right?
Yeah, and then you're not worrying about it just being isolated to elbows and the equipment at the destination.
Sure.
It could even get really bad for your straights.
No, absolutely, absolutely. So what kind of issues, do you see with resin quality and process quality when you end up creating these longer pulls and higher velocities?
Well, if you're wearing through lines, you can introduce contaminants, which could be a problem.
Absolutely.
Right.
If it's a more sensitive or brittle material, you could be dusting your material, or you could be creating angel hair, which will cause plugs and make it harder for you to get the proper throughput of your material to your destination.
Sure.
So it could actually inhibit, it could cause starving of stations, so on.
Well, and so just the inherent nature of the way pumps have been designed, and we've talked about it many times, which is a lot of parts of the plastic process have changed dramatically certainly over my career of 30 plus years, but I think over even 50 or 70 years that plastics has really been evolving. Conveying pumps really haven't evolved that much, though, have they?
No, I wouldn't say much. I'm looking at older designs, comparing it to some of the pumps that we put out there now, along with competitors. They're pretty much the bare bones, just make the system work.
Lobe style, PD pumps, electric
pretty
motors,
common.
Yeah. And there have been some control things that have come along, like variable frequency drives and speed control. Yeah. But again, existing pumps have their limitations. There's only so much of a range that you can use before you start overheating motors, overheating pumps. Yep. So it's some help, but has not really solved some of those more significant issues, right?
Yeah, especially when it's a lot.
Yeah. So let's talk then about what as Novatec started to look at this issue more closely. What were some of the considerations, and then how do we change the basic dynamic of how a pump is built, how it acts, and how it addresses some of these issues that are inherent with the process?
Well, we definitely wanted to try to find a way to make it a more intuitive product. Instead of having everything based on time for maintenance and, you know, having it up and running and not be a product where it fails, we got to fix it.
Sure.
So we wanted to make something that was a little more intelligent, that would be able to provide very good benefit to the end user. And one of those things was better energy efficiency was one.
Yep.
Another was maintenance prediction.
Okay. And obviously, you know, we've talked about temperature generation with pumps. We've talked about noise. We've talked about, you know, the drive mechanism, and obviously all those things are maintenance points and so forth. So, you know, let's talk about the heart of the development that was done, which is the EV type motor development that Novatec undertook. Fred, talk a little bit about what the principle of that is, and what is the basis of those motors, and why are they important, why are they special?
Right. Yeah. So So obviously, EV, you know, vehicles are getting more popular. That technology's been out there. That motor type technology's been out there, but there hasn't been really anything tuned or designed for industrial type purposes.
Sure, some big motors, but really for our type of purposes, you know, in the reasonably small 3, 5, 7, 10 horsepower type things, not really that common, right?
No, it isn't. So we had to apply those type of technologies to be able to use in our environment, you know, and for our applications. So we actually designed our own motor.
Okay, so this is a proprietary motor.
Yes.
Novatec is having built, right?
Yes. Yep.
And what's special about this motor? What's different about this than a standard induction type motor?
Right. So obviously the key thing we were talking about is energy. So we have about 40% less losses than a traditional induction motor.
Okay.
Okay. So obviously saving energy usage, and part of the reason or side effects of that energy efficiency is it runs cooler. And another benefit of it is that it's also more power dense. So we're actually able to use the motor and get more horsepower out of it, more torque than a traditional induction motor. So, you know, those were all part of that. Another benefits of the motor is that we have a better constant torque throughout its entire speed range.
Okay.
So that means we can push it, you know, to higher and lower speed ranges and still be able to maintain the torque that we need to be able to do the work.
So Ryan, I'm going to throw it to you because I always ask you this question when we talk about this technology. So this motor is of a class and name of?
It is an internal permanent magnet synchronous reluctance motor, or IPM syndrome for short.
Okay, and so again, very similar to the motors that are used in a Tesla or a Rivian vehicle or those types of motors, right?
Yeah, where energy efficiency is very key, plus power.
Okay, okay, and so we have this motor development, and that's kind of interesting and cool. But how does that? Why do our viewers care about that, and how does that apply to conveying resin within a plant?
Well, with this motor technology, we need to use a variable frequency drive as a base for the product. So we're not having a separate lower model that has a motor starter. It comes with a variable frequency drive to start because it's required to operate this technology. And because we were able to do that, and because of the lower and higher RPM ranges that we're able to operate with, we were able to actually eliminate the belt drive from the system. So we get rid of one more maintenance point and able to shrink down the overall footprint of the pump. Okay,
so the new pump series, the Infinity series of pumps, is a direct drive pump.
Yes.
Right. It's got this new motor that gives you a wide range, less temperature generation because of the inherent technology.
That's right.
Talk about the noise issue, because that was one of the key things that we talked about initially, was really big part of conveying and what we're trying to get around.
Yeah, so in addition to working with this new motor technology, we wanted to build upon one of our existing products and make it even better. So by taking some of the features of our silencer series, we were able to develop this pump with this new motor technology. So we utilized vibration pads, we utilized an exhaust stack, but we improved it by making it more of a resonator. We made sure that the silencer is still mounted vertically.
Which is a big thing, right?
Which is big because a lot of pumps out there right now have the silencer made to be fit into a very I would say compact per the design, nested really nice into it, but it points horizontally, which puts it against the wall. It puts it at the person.
So you're throwing sound right at the operator.
Right.
So we're doing this to break it above ear level.
Right.
And then there was other things that we did as well. We muffled our vacuum breaker valve because inrush air at the pump generates a lot of noise. So we added beyond that to actually have more sound abatement on it. So we enclosed the blower, we enclosed the motor, and encased it with some sound deadening material that allows us to, it looks kind of like a claw pump a little bit, but it helps to create a noise captured environment and drops the noise even further. We want to make sure that this pump is more beneficial to the end user so that they can have more flexibility with how they install it.
So what's the sound level on this new pump now? What's the target? What's the reality?
So right now, if anyone's familiar with our other series, we were under 80 dBA with a 10 horse.
That's the silencer
That's
series,
the silencer
right?
series.
And that was the
Now with the Infinity series, we have expanded that to have 15 horse under 80 decibels.
Okay. So and 80 decibels is kind of that break point you look for OSHA, for
That's right.
just environmental friendliness and so forth,
Yes,
right?
absolutely.
No hearing protection required in most cases and so forth.
Yeah, if anyone was at the NPE show, last show, we actually had one of our pumps running in the booth.
I remember that we had a lot of people come in because we were running a conveying system, right? Clear glass lines, so everybody was intrigued. And wanted to know where the pump was that was running.
It was right there, right on the aisle for everyone to see. And
yeah.
You could talk right over it.
Yeah, in fact, I found it interesting that when we started the pump up on Sunday, before the show opened, you could hear it, but it was running at about 68 to 70 decibels or so under load.
Yeah, it was a relatively small version.
Yeah, and then, but on Monday, when the show actually opened, the general show drone is higher than that. So it really, the pump was almost unnoticeable.
Exactly.
Yeah, it was very interesting. We have this pump. It's based on proven technology it's just been improved upon. So there's not a lot of risk in terms of those things. But how do we apply this now to solve some of the other issues, like the velocity issue, like the distance issue, and not having to isolate pumps in their own room and things like that? So I think it's probably a combination of both of you, the placement of the pumps and how we design a system differently because of these pumps, and then how do we incorporate control technology to take advantage of all of this capability.
Yeah, so now that the pumps are quieter, you're able to have more flexibility with where you place your pump. And you'd have more of an opportunity to actually install it where it would be ideal for the system performance, which could be right around where the destination is, leaving it out in the open for people to be able to view and understand the current status of the pump.
Okay. So it's not hidden away, so people are paying attention to it, and it's closer to where you want to use it, so you're shortening up those distances, those velocities, and everything else, right?
Yeah, exactly. But we're not saying people can't put them in remote rooms.
Sure.
But we have another feature of the pump that will actually allow you to do that without having no idea of what's going on in that room.
And that's a nice throw to Fred, because that's part of our control integration. You're talking about pump sense, right?
Yeah, and that is local on that pump.
Yep. So Fred, tell our viewers a little bit about pump sense. It's not new, but it is rethought.
Yes. Yeah. So we've had pump sense around for about 10 years now, and we've showed it in some previous shows. And but yes, we have reworked it, and it is a standard offering with the Infinity series currently. So some of those points we're talking about with putting it into a remote room or things like that, out of sight, out of mind, so we have our pump sense health. So locally you can go ahead and see things, you know, and LED.
And that's an addition. That wasn't there before,
That's correct.
right?
That is
That's
something
right.
we've added recently.
So the visual cues are new.
That's
Yeah,
correct.
we wanted to make it real simple and easy, so that you
Right.
just take a look at the pump, you know what the status is.
And
So,
right. So it's you know, see the what the viewers are seeing,
Right.
the three lights, the LEDs,
Right.
and they're basically green, red, yellow, telling you.
Exactly. So quick, simple things that give, you know, the any type of maintenance person a quick, or even an operator might be in the area can see, you know, if there's something that might need to be
Sure.
maintenance wise done soon.
But that pump will still communicate with
Right.
control systems and give you alerts and things like that.
But the key point we also were trying to do is, in case they do want to still put it in a pump room or something like that, we can get access to that data. And the other beautiful thing about this is that people just don't have to do maintenance to do maintenance.
It's
Okay?
predictive, right?
Exactly. So we are going to be able to, using our sensors, there's the two real critical parts of the pump maintenance that need to be done. And number one would, of course, be filters.
Sure.
You know, pump filters is a critical part of it. And we have a vacuum sensor on the unit. And so one of the things that this new AI kind of control system that we have on our pumps is we can go ahead and indicate filter issues for the customer.
Okay, so when they're losing vacuum performance,
Exactly.
they know they have to address the filter climate.
Exactly.
Okay.
So then the second major thing that we're detecting is through vibration, through part of our vibration sensor technology, is we're actually the status of the oil.
Okay.
So whether so the oil that's in the blower might be low, it may be contaminated, and we can bring attention to the maintenance that is required on an on-demand type application.
And again, not rocket science technology. That's been out there for a long time, where you're isolating vibration frequencies and you can tell what that frequency is telling you. That's used on a lot of different applications, including automotive and aircraft and everything else.
That's right.
But again, now transitioning it into an industrial application,
That's
right?
Yep. Yes, and so another big part of our sensing, vibration sensing, would be bearing status. So if we see some bearing starting to fail, those type of things, we can also bring attention to that.
Okay.
So instead of having that, you know, interrupted production line issue, we can, you know, flag that when they have time.
Sure.
We can take it offline, and you know, so we can do that in a scheduled manner instead of an unscheduled manner.
Gotcha. So, and the other piece that the technology, as you said, has been out there for a long time,
Right.
you know, 8-10 years.
Right.
But I do know that one of the concerns from a lot of facilities has been the access to the internet for storage of data and so forth.
Right.
And understandably so.
Yeah.
IT security is certainly a major concern for most companies. What's different about this? This iteration, it does not have that requirement.
That's right. The original version, we had a cloud type solution. Obviously, the benefit of that is that you know, we have the software that's, you know, constantly can be monitored and those type of things.
Sure.
But of course, the issue is IT people and the security infrastructure of
and it's
the
an
plant.
understandable concern.
Absolutely.
Sure.
Yeah.
So now all this is all in the plant, all within on-premise solution is what we call it.
Sure.
And so now we don't have to worry about it having to go, you know, outside. It's all contained within their plant.
So this can all communicate to an MRP system. It can communicate to a maintenance package. It can communicate to our control, you know, our centralized FX or FT controls.
That's right. In addition to its own gauges and web pages that it has itself, that you can get access to by simply going to a URL type of internal web page, you know, that it produces. Yes, we can also integrate that with other.
Sure, and that's we're in an AI world now. 5 or 6 or 8 years ago, we were in an industry 4.0 world. But I think that the lines of those two terms have kind of blurred at this point, and it's really about machine intelligence and communication, and that's what this package really brings, right?
Yeah, absolutely.
Yeah. So we touched upon, Fred, you know, controls are what's going to allow us to leverage some of this capability that this new pump has. So talk about, we have customers and partners that have installed bases of equipment, and they have a plant that's running and it's running fine. Maybe some things are getting a little long in the tooth and they're saying, well, you know what, we should maybe put some new pumps in, but I'm not going to change my whole plant. I don't need to do that. What capability would a company get out of this new pump if they just wanted to buy the pump and put it in place of something they have, or maybe they're adding a couple machines and just need a little bit more capability? Will they be able to leverage any of this gee-whiz technology that comes with the pump without doing a wholesale change?
Yeah, pretty much everything we've been talking about so far. The lower sound levels, the energy usage, reducing their energy usage.
Relatively smaller footprint.
Yeah.
So it could fit any existing pump footprint.
Yeah, exactly. So obviously having it as a first, they want to try it out and just replace an existing pump that they might have. And just put it into an existing line with existing controls. And you, like I said, you're still going to get those features. You're still going to have the simpler maintenance, that we talked about, the simpler design because it's direct drive. The no belts, less bearing wear, and because of the loads. By direct drive versus using shivs and belts.
Well, Novatec's always had a feature that other manufacturers haven't necessarily leveraged, which is an idle mode on our pumps.
Yes.
So they don't just start and stop; they go into an unload situation, and so forth. This pump has that same feature, but now it's actually built into the pump, right? So
that's right.
So even if you have a different control system, you still get to use that feature, right?
That's right. That's right. So we still have a idle mode that we've always had, but now we just take it to another level.
Right.
With this pump.
Because it was always built into Novatec's control, really,
That's
not
right.
into the pump, right?
It's still built into the control.
Right.
This is just you just need to have that operation. Yes, we can offer like something that'll allow you to have a breaker valve operation if you don't have it already.
Yes,
but
that's
what
right.
we've done is we've actually, as Fred was saying, we've taken it to the next levels, and it actually utilizes the variable frequency drive. It gets a signal that tells us, hey, we're in this brake mode. It'll actually ramp that motor back down. So you can actually take advantage of better energy savings. You can let the blower cool down, but not take as much horsepower, as much load, which helps with that energy reduction.
Well, we keep mentioning energy, and pumps don't use a tremendous amount of energy, but they do use energy. But along with energy, one of the other things that is a big focus for most companies in the world, and most people, I think, is the environment, carbon footprint, and so forth. And there are reporting requirements for that for most industrial applications. So this lets you actually take advantage of gaining some positive move on your carbon footprint as well, right?
Yes. And so a brief couple of facts related to this type of thing. So motors are about almost half the world's energy usage.
Wow. I didn't realize that.
So it adds up quite a bit. So even though there might not be that high in our cases, they do add up. The other thing is that they're expecting within the next 15 years or so that a doubling of the amount of motors that are being used in the world.
Wow.
Right.
So that's becoming more and more of a focus. It needs to be. It should be, yeah.
So with us having a 40% reduction in our losses, and having these much better energy usage points, it really can add up quite a bit.
Absolutely.
Like I said, that idle mode we were talking about, for instance, we were talking about the show and the pump we had there, we were under 1 amp of power when we were at idle mode.
And that was a 5-horse unit.
Yes.
Yeah, I mean, that's pretty darn low.
Right. Yeah, during the idle mode.
Gotcha.
And I just want to mention one more thing. When we ramp that down during idle mode, we're not only saving energy, we're saving noise.
Oh, absolutely.
Yes.
Yeah. Lower speed, lower sound levels, right?
Yes, absolutely. Because during idle mode, you're pulling air directly at the pump, which generates a decent amount of noise pulling through a small orifice.
Sure.
So ramping that down, noise gets reduced.
Okay, that's a great point. That's very important.
And that goes back to those OSHA requirements as part of that time-weighted average exposure that they have, that they do the calculation.
Sure.
And that helps with that immensely.
So let's talk about that. Those are the benefits that anybody's going to get
That's
that
right.
utilizes this.
That's right.
Novatec has two different levels of control. We have for quite some time.
Right.
The FTS Flex Touch
Yep.
control, which is our basic series, and then our FX control.
Right.
So what do folks get if they have need to or desire to take the next step?
Right.
They have they need another control, and they say, tell me why I should buy an FTS or an FX3.
Right. So the FTS has a key feature that we've added that we can take advantage of with this pump is the velocity control or airspeed control.
Okay.
Okay. So this goes back to some of those things we were talking about before with distances between. So we might have a pump that's located 200 or 300 feet away from some type of destination, where we might also have it near 20 feet away.
Sure. Yeah. I mean, on any conveying system, you've got machines that are maybe in a row in a bay. You know, most of our viewers, I'm sure, can envision that, or they can walk out the door in their plant and stare at it. And so that machine that may be 200 feet down the row has a different need in terms of the amount of resin and how much energy it takes to get it there, as opposed to the one that's 30 feet away from the pump, right?
Yes.
Yeah, and you have to size that pump to handle that for
The worst case, right? Yeah.
Right.
So now the difference is this is going to let you do determine the velocity point to point
For each specific station.
Okay.
They have the ability to do that.
And that's in the basic control.
Yeah.
Okay.
With the FTS.
Okay.
Yep. So with the FTS coupled with the Infinity series pumps, we can take advantage of those features.
Okay.
So that'll help with all the noise we've been talking about. Lower velocities, less noise, less wear that we were talking about. We were talking about wear and abrasiveness. We were talking about digital herring and all those type of things.
More energy savings.
Yes, more energy savings because we're not working the pump as hard.
Okay.
Yeah, so that all cascades.
Now I've got a bigger expansion, and I say, nope, I need the flexible control, the FX3.
Right.
What do I get? What additional value do I get out of employing that control?
Right. So obviously we were talking about the features that we've already talked about, and in addition, one of the neat features that we have is the pump's able to detect for instance, a high vacuum type condition when it's trying to load to a station.
So like a line blockage or something.
Exactly.
Like that. Okay.
So the FX3 type controls can see that, that blockage and can see those high vacuums. So what we actually have a feature in there that will allow us to adjust the pump's vacuum relief point to operate at a higher vacuum level.
Okay.
Okay. Work it harder for temporarily to actually unplug the line.
So not only can we speed the pump up,
Yes.
but we can actually crank up the vacuum level, maybe 13 or 14 inches of vacuum as opposed to 11 or 12, right? As in a normal situation.
The way it would work in an incremental basis.
Okay.
Until it is cleared.
Okay. And I know you guys have told me about, and I love the fact that it not only will it do that, but then it is also somewhat diagnostic in that it's going to give the operator an alarm or message and say, hey, listen, I loaded the station, but I had to do this.
Yep.
So there may be something wrong. So it's not just going to do it and then go on about its merry way. There may be a bigger problem it's going to alert you to, right?
Yes, it gives the user the ability to know it had to do it, so they can address the issue and correct it.
Good.
Yes.
Good. Gotcha.
And in an unfortunate case, it was maybe so clogged or so plugged that it isn't able to.
Right.
Then it will actually disable that station
Well,
and alert the operator.
And it will prevent you from wasting all that time from trying to load it.
Right. So you won't be wasting pump time
Or
trying to
starving
load
other
that station and potentially starving other stations. And it's not going to do the wear and tear on the pump trying to constantly pull.
I'm sitting here and I'm thinking to myself, I sized the pump to handle the longest convey distance I have, and so it's running all out there.
Right.
It's already going 100%. How is it going to get faster and be able to break that plug?
Well, we have a little extra to push.
Okay.
So we're able to push over 100% with this motor.
Okay.
So in the temporary fashion to help unplug those lines.
Okay.
So each pump with this motor is designed to a specific CFM and vacuum level, and it's never at the max RPM of the motor.
and that's the, you know, our little tongue-in-cheek
Yes.
joke. And we,
Yes.
some of you who may have seen us at NPE,
Yes.
that's our ludicrous zone. So, like the movie, you know, our new pump has the ability to go ludicrous speed. We haven't gone plaid yet, but we can go ludicrous speed. So that is an important factor, and it's one of the things that's important about this motor is it can go lower lows than a typical variable frequency
That's
inductive
right.
motor, but
That's right.
it can also go higher highs.
Yep.
So instead of being, you know, a operating bandwidth this big, it's an operating bandwidth this big, and it gives you a lot more flexibility to mix line sizes in a system, to mix dramatically different distances and throughputs and things like that, and then incorporate things like this line plugging braking. So you know, we've covered a lot of ground, and I appreciate both of you and all the insight. I also appreciate our viewers and their attention and their interest in this. The most important thing we'd like people to walk away from this is, one, we know that resin conveying is challenging. We know that resin conveying is not something that most processors want to do. You don't make money conveying resin, you make money making parts. And so we focus every day on trying to make it as easy and as non-invasive as we possibly can on your process. And we think that this motor development, this pump development, and the added features that our controls bring are all tools to help with both designing more logical and comprehensive systems and operating more efficiently with less interruption in your process. So we'd be more than happy now to address any questions that our viewers may have. And certainly we always welcome you to get a hold of us at Novatec, and we'd love to talk to you about your challenges and about what we might be able to do to help you. So Joe, please, back to you, sir.
Thanks, Tim. Great job, everybody. You did a super job talking about how you're meeting some of the challenges in pumps, and pretty interesting solutions anyway, as far as getting rid of noise and smaller footprint and energy usage and some other things that you talked about anyway. At this point, it's time for questions, as Tim said. To ask a question, you can just type it into the Q&A box. You'll generally see it at the bottom of your screen, sometimes at the top, and we'll answer your questions in the order that they are received. We're going to start the Q&A. I have questions I can ask on my own too here, but I think we start with just some product questions anyway that we have, just to clarify a few things anyway. First of all, what's the horsepower sizes that these are available in? What can you get these in?
No, great question. That's something right up your alley, right?
So with this new motor technology, we're able to fit a lot more horsepower into a smaller, denser motor. So we actually don't size our pumps solely to horsepower. There's actually a little bit more that we like to know for a system that will be able to help us size one or get you the right pump. We work towards looking at line size and your available vacuum level. So we still can say our pumps are 3 horse, 5 horse, 7.5, 10, 15. But that will be indicative only against the line size that it'll be made for. So we have our 1.5 and 3 inch, 3 horsepower, and 3 inch with 15 horse.
And that's really how it's always been sized, right? I mean, it's not, this isn't new in that really pumps have always been sized based on throughput and line size. But as an industry, we've found a convention of just equating that to a horsepower size. And so we'll still list them that way so that they're familiar to people.
And we'll help you select one. If you give us a horsepower, we will ask you what line size system you have. And we may be able to size you with that horsepower, or there may be a more efficient model, or you may need a little bit more horse, because between competitors, there could be different horsepowers against line size.
Well, what's interesting now is because we're going to be able to vary these pumps in the terms of the speed and the throughput and the airflow so much,
it's a little more flexible.
We may have situations where we, you know, as we did with our system at NPE, we may mix line sizes and say, you know, what really makes sense is for you to have this size pump and use 2.5 and 2-inch lines.
Yeah,
You know,
exactly.
so there are some variations that are a capability now that probably weren't before, right?
Yes.
But to answer the question, they are in general 3 to 15 horsepower is what this general pump is available in this configuration, and there are both low vacuum and high vacuum versions of that in those horsepower.
That brings up it's a follow-up question that I have with it. How is important is it for the customer to get with you to go through the configurations and what they need for their plant? How involved are you in the setup and the training for some of this anyway?
Well, the good thing is we do have some data sheets that are available.
Right.
So then that'll give them a good baseline for what they may need for their system. If they have further questions, we are always available through our sales and service department to answer any of those questions.
And we do have, we've got technical people here that are always available to help, but then we also have field-based people that are more than happy to come to your location and both look at what you're trying to accomplish and then help with that solution. So whatever level of involvement a customer would like us to have, we are more than happy to have. We want to make sure that we get you the right solution.
Actually,
Super.
one of the interesting facts also with this product, though, is if they happen to have one of our infinity pumps, the customer themselves can actually see how much more pump availability they actually have.
That's a great point. Why don't you explain, just real briefly explain that. There's a feature on the pump sense that will let a customer kind of know that.
Right. Yeah. So part of the gauges and the data and the information that you get is you're actually going to see how much time the pump's in idle, how much time the pump's actually being used to transfer material in a normal operating range. So you'll actually be able to, and then of course just being off, but idle/off is the same thing. So you can actually see how much more pump capability you actually have available for that pump.
Sure.
Which is great for us because we've designed it for something where we talk to the customer ahead of time and we've engineered this project managers and we deploy it, but things change, customers move things around, change things. So we go to expand later on, it might not actually have the same throughput capability that it had at the time we initially sold it.
Yeah, so that's right. That's a great tool for, that's built into these is that people can see, are you utilizing 50% of the capacity of this pump or 80%? So if you're planning on putting 3 more machines on this line, you can somewhat self-diagnose whether you have some capacity left to handle that.
That's right.
Yeah, that's a good point.
Excellent. That's a great data to use to see if you're using it optimally, I guess, in some cases.
Absolutely.
A question from somebody from the attendees: do the new pumps still run in the 7 to 9 psi range?
So
we're if that
inches of vacuum.
Inches of vacuum. So these are vacuum pumps, so we wouldn't technically be running in PSI.
Okay.
But inches of vacuum.
I'm sorry, it means HG. The person clarified it here. It didn't mean PSI, I meant HG.
Sure. Mercury.
So the vacuum pumps for this series, not the high vac configuration of it, we are between 9 and 11. For operation with roughly a 12.5 relief. For the high vacuum, we're closer to 14. So you would use the high vacuum in like longer distance conveying situations or higher throughputs. But yeah, for your standard PD style, right around that 9 to 11.
The high vacuum is a nice option as well for problem solving, right?
Yeah,
I mean, if somebody's got 5 machines on a system and they're just not keeping up. Either they've put larger tools in, maybe they're demanding a little bit more for their system. They can swap out a standard vacuum level pump for a high vac pump.
Yes.
And get more throughput through those exact same lines and configuration, right?
Yeah, especially if you're familiar with our MVP series, it will equate to that. It's just a more technologically advanced smart pump
and more compact package.
Yeah, much smaller.
It is
package,
much smaller.
So it tucks into an existing spot much more cleanly.
That's right.
Super. Here's a question. You may talk about resin a little bit, and you said there's some highly specialized resins out there too. Glass filled stuff, other things that are on the marketplace. Can you explain a little more detail how this system protects your resin from damage generally? It prevents angel hair and dusting. Is it because it can convey it more gently, or are there other variables involved in that?
Well, I think, explain the ramp up and then the level off and the speed control. So
So Like we talked about earlier, we do have the ability to do some velocity control with this pump and with our FTS and FX3 type series controls. And so what we can do is we can reduce the velocities of those engineered resins. So by conveying at a lower velocity, we can help reduce the impact when we're hitting an elbow. So if it's a more fragile type, we can also reduce the amount of heat that's generated as it's going through the elbow if it's a softer material. So that's how we're going to be getting more effective transfer of the material and get a higher yield out of the plastic.
Well,
Yeah, so
go ahead, please.
Yeah, so we're using our control platform to control the variable frequency drive per station, given 4 different speed modes. So you'll be able to have adjustability per station for what you are conveying. So you can have a mix of glass-filled resin on one station, a sensitive resin on another, or regular polypropylene, and you can run all those stations at a different speed.
Right.
And what we're doing is, it's not just going to run at that speed. We want to make sure you get that material moving first.
Yeah.
So we'll actually run at full speed for the first couple seconds.
Yes.
And then we'll ramp it right down to make sure that we're cradling the material through if you decide to choose the slowest speed, or be able to give it a little bit more pickup at like more of a target speed, something more ideal for that particular station. Or if, all right, you're running behind, but it's not a glass filler resin, have it at the fastest speed, 100%, and be able to get it done that way. So this is a little bit of a user input, but you'll be able to set your station as you need it to be.
Yeah,
that's super. Nice detail.
Yeah, it makes sense. Some more gentle, some not, depending what's needed, I guess, anyway.
Yeah, the key was that we still needed to get that, initial pickup velocity to get it moving,
Yeah, it's actually a little bit strange when you're standing beside the pump in a plant, because we have a number of these already installed, and the pump comes on and it's at full bore, and for 2 seconds, all of a sudden you hear it go, woo.
Exactly.
Well, what happened there? Well, it's because you want to pick it up, but then you want to slow it down.
Right,
So, yeah.
exactly. Once you've gone to that static friction to that dynamic friction level.
Exactly. Yep.
Great. Well, a couple more questions from the audience here. Can you add the Infinity Series pumps to be used as a backup pump to a standard VPDB style pump?
Yes.
I said that's a tongue twister. Sorry about that.
Yes.
Yeah.
So with our pumps and even with some of our competitors' pumps, yes, you can use this as a backup pump. Because of the variable frequency drive, you will actually be able to dial it in to match whatever pump you're using it to back up.
Which is nice, because if you have 2 different size pumps, maybe in differing systems, you potentially could back up both pumps with one backup and run it at a different speed depending on what it's doing, right?
Yeah, ideally you want to have it within a line size.
Yep.
But you do have some flexibility. But yes, it could be used as a backup. I would see it more as a primary.
Yeah, that same here. I would have the other pump be the backup.
There you go. Here's another question. Can your VFD adjust according to different sources to keep the same volume of throughput rather than speed, such as going from a smaller line size to a larger line size and at different lengths? How adjustable is it to that?
Right. So we have also, just a quick little more info about it. We do have predetermined kind of journal settings that we've come up with. Those can be tweaked if needed to adjust those. But one of the speeds that Ryan mentioned is that we have one of the speeds that it's in there. We have these different speeds that target and different, full speed.
I didn't really talk about what they were.
Exactly. But what he was referring to is that we also have one of those speeds is an additive mode type situation. So in the additive mode type, we have the ability to use different line size than what this pump would normally be designed to be used.
Or dramatically different distance. So if you're pulling resin from say your silos, which may be 200 feet away, through a 2-inch line, and you want to fill a blender from right beside your press or a feeder for colorant, maybe you're only going to use 1.5 inch line there.
Right.
And so it can accommodate both of those and run it at the appropriate speed
Right.
to get the appropriate throughput without. That's always been the challenge, is when somebody has a 3-inch system and they want to feed 2% coloring from right beside the press.
Yeah.
Very difficult to do with this pump, because you can ramp that baby so far down.
Yes.
You really can both mix the line sizes, but also
Right. And so like
so the short answer is absolutely you can do what you're asking about, and within reasonable limits.
But the control can go a little bit more beyond that, because it also can actually energize or fire external valving.
Right.
That can create a bleed.
Yep.
For even more reduction.
Yeah, we can actually go to a smaller line size when we do that.
Right.
Yeah, there are all kinds of third step tools that can be, if the need is wider than what maybe just the capability of the VFD is, we have other tools that can be utilized for that purpose as well. So without a doubt, we have, I think, built enough flexibility into all these tools where it really is, Joe, back to the original question, why a conversation is really important in sizing and specifying these things.
Yeah, like it can be customized to what you need, depending what your situation is, I guess.
Yep.
What's the general cost range of the Infinity series pumps?
So Ryan, if you want to address that, it's in general.
So I don't have the numbers in front of me,
Right.
but in general, if you're looking at, let's say, a positive displacement pump, for example, one of our VPDVs, and you had a sound enclosure on it with a variable frequency drive, we're actually less than that.
Right.
And we're actually adding more features in this particular product series, including pump sense, including a direct drive system, and additional sound abatement. So it would be comparable, maybe a little bit better of a cost point, but I don't have the numbers in front of me.
There's a slight premium if somebody's utilizing a bare bones PD pump, with a motor starter, an on-off motor starter. There's going to be a slight premium on these pumps because there is a variable frequency drive that's required on these pumps. So, somewhere it could be anywhere, depending on the size, between 10 to 25% or so, 10 to 20% premium over a base pump. A standard PD with a variable frequency drive, it'll be a very, very close comparison cost.
Right. That being said, though, the premium you're paying is going to be paid back in maintenance and energy savings.
Sure.
Okay.
Yep.
Yeah, I was going to ask about the ROI with it too. So you get the energy savings, you get the maintenance savings with it too.
Right.
And so
yeah, and we certainly warranty this pump much longer than standard warranties in the industry. So it's one of the advantages of having a motor that you've designed and you have built for yourself is you're able to stand behind it a little bit better sometimes.
That makes sense. Do you have another question in the audience here, do you have fully automatic backup? Do they lead lag based on hours?
Yeah, we do. Yeah. We do have a automatic backup type feature set. We have valves that we can help also with that would be able to install in the system so that the pump can automatically take over and redirect the vacuum in the air to a backup
Reassign
pump.
the stations to that pump.
Yes, and reassign all the stations. So that can be done on the fly. You don't have to necessarily do it right in the middle of a loading station, but it can be done. It can be
and it can be done with our Infinity series as well.
Yeah, exactly.
Yep.
Super. Another question. This person has pumps in their plant right now. Are these pumps stackable? Can you do that?
So the pump, the way it is designed, yes, we actually have a stacking stand that we have prepped for it. It'll be kind of a straddle stand with a slight offset, kind of like what we do with our silencer series. So it won't be a direct stack over, but just a little bit of an offset there.
Yeah, if you can envision, because of the vertical stack, the exhaust stack, there's a slight offset so the stack can clear the one on top of it. But yes, they are stackable for space efficiency.
Right. And I know you mentioned a bit, I guess I call it retrofitted, or you can use it with existing equipment if you want to get started. Is that a key feature of this anyway? And you maybe clarify that a little bit, how you can use it with existing equipment?
So it's just like any other pump. You're going to hook up your starter signal, your valve, your vacuum load or vacuum idle valve signal, your 24 or 120, 24 volt for this pump. And you'll hook up all those to your standard terminal blocks, and you'll be able to run this. It'll just be at a fixed speed with this variable frequency drive. But it'll have, if you have idle mode with your control, it will ramp it down during idle. So you'll have, there are features with just the standalone pump that can be used as is with any control system.
Sure.
Yeah.
So, yeah, either way, especially if you want to ramp up into something more, but it's a good way.
Yeah, the dynamic speed control, Joe, is what you probably give up with a more basic application.
Right.
That's right.
Yeah, that makes sense. And I imagine this can be integrated nicely with other pieces of the machine anyway, of the machines and other things, and make a total system with this too. Does that work well with that too?
Oh, absolutely. Yeah, I mean, and in fact, that's where we expect and where we have already seen the most interest in application is in new integrated systems like that. Because again, people are putting in a fresh system and they're wanting to take advantage of the latest technologies and so forth. We do have a couple that have been sold and have been employed for retrofit on existing equipment. But as we see with most developments, new systems are usually the early adopters on some of this. So yeah, it's fully integratable. It has all the communication capabilities for AI and Industry 4.0. So if somebody wants it to talk to their molding machine, control all those things, it's certainly capable of all of that.
Super. Yeah, I know that was I just kept back from K-Show, and that was a big topic there was integration. So it's great to have equipment that can do that. That's all the questions we have for today. Terrific conversation, and the question and answer period was really great too. Again, if you want to reach out to Novatec to discuss more, the URL is on the screen, novatec.com/Infinity Series, and they'll be glad to help with anything. Again, I want to thank left to right to be Fred Eichhorn, Tim Nagel, and Ryan Ismerlian. And great conversation and great discussion of some new technology that's out there. Again, if you want to review the webinar, it'll be posted to the Plastics News website, the webinar section of our website, within 24 hours. So you can watch it there again if you'd like to. Again, I want to thank our great panelists and thank Novatec for sponsoring this webinar, and thank everybody for attending. Thank you, and we'll see you at the next webinar. Take care.
Thank you all.
Bye-bye.